Another very important tool to have to be able to solve for unknown sides is the law of sines. And what I really like about the law of sines is that it can work for any shape, right? Well, let me specify. It could work for any triangle, pretty much, as long as uh, the criteria is met, which is very easy to be met. Whenever we did SOHCAHTOA, you could do law of sines. And this is another reason why, quite frankly, I just prefer the law of sines um, over SOHCAHTOA because I can use it when it's a right triangle and when it's not. But anyways, this is how we use it. Law of sines is just a simple proportion problem. A over the sine of A, B over the sine of B, and C over the sine of C. When you're doing this, again, eventually you'll be able to do this in your head. But at first, for practice, it's a good idea to write this stuff down. So let's say you were given this problem right here. The first thing you want to do is you want to label, and you want to label your corners using the letters A, B, and C. Now, quite frankly, it does not matter how you label, okay? But if eventually when we do law of cosines, so that you don't have to remember a whole bunch of formulas, wherever x is, just go ahead and label that C, okay? So let me go ahead and write that down. Just, let x be your C. And this is going to save you so much, trying to figure out what's what, especially when doing the law of cosines. So if this is C, right, because here's my x, here's how you're going to label. So if this is C, this is your side, right? Then the angle across, that's going to be C. All right, and then the rest don't really matter, right? If you want to call this A, the one across is A. If you want to call this B, I mean, it's all that's left, the one across is B. Things to note, your angles are your capital letters, and your sides are your lowercase letters. So now that we have that, this table here is there just to help you out. Again, it is expected that later on you could do this without the table, but for now, for organizational purposes, let's label everything we know. Little a, I know is 10. Big A, I know it's 40. Little b, I don't know it. Big B, I don't know it. If you think about it, we could find it, but let's just pretend we don't know it for now. Little c is x, big C is 60. When you're looking at this, anytime you have two angles here, you could technically find the other one because the angle should add up to 180 degrees. So that's 40, that's 60, that's 100. So 100 minus 80, that's 80. So I know that this has to be 80 degrees. Now here's what makes law of sines so special and so easy. And this is where the table comes in. You're going to look for pairs. Oh, I have a pair at the A's and I have a pair at the C's. If you have pairs, that is what you're going to use in your setup, because law of sines just requires a fraction equal to another fraction. And you can see, I know there's three fractions, but at all times you only use two when you're solving for each problem. So here we have A and C, so we're going to use these two. So you could see how the 10 is going to go on top. And in the bottom, we're going to have the sine of 40. Make sure you include sine, don't just put 40. Here, same thing, it's going to be x, and it's going to be the sine of 60. And now all we have to do is just cross multiply. When we cross multiply, you could think of, if you had regular numbers, but it's going to be 10 times the sine of 60 is equal to x times the sine of 40. But now if you think about it, algebra tells us that we're going to have to divide by the sine of 40 to leave x by itself. And if you keep that in mind for future problems, basically it's going to be these two divided by that one. the one that goes with the x. So when I come here to my calculator, I'm just going to put 10 times the sine of 60. And I'm going to end up dividing by the sine of 40. And I find out that x has to be 13.4. Always ask yourself if your answer makes sense. In this case, it does. Because between these two, the 60 is a bigger angle. So you would expect this to be greater than 10. It is. Perfect. All right, let's go ahead and do one more here. Here's how you would do it without a table, without having to label. Just look at what's given. I have a 7, and that 7 is across the 30. So I already know it's going to be 7 over the sine of 30, just like that. I have an x, and the x is across the 120. So x over the sine of 120. Again, just like that. So now we just cross multiply the same way, and if you remember that quick little shortcut, it's going to be 7 times the sine of 120 divided by the sine of 30. So 7 times the sine of 120 divided by the sine of 30. So we get an answer of 12.2. X has to be basically 12.12. That easy, guys, that easy. All right, I'm going to do an example where now we're going to solve for the angle instead. We basically do the same thing. So again, if we go straight to that quick little shortcut, you can see how we have a 12. And so the 12 is across the angle x, so this is sine of x. The 10 is across the 50, so sine of 50. I'm going to go ahead and show you the algebra on this one, but it's pretty much the same thing. You can see how we have to multiply both of these. Okay, so this becomes 12 times the sine of 50 is equal to 10 times the sine of x. But we got to leave this part by itself, so we have to divide both sides by 10. So this becomes 12 times the sine of 50 divided by 10 is equal to sine of x. And just from SOHCAHTOA, if I'm looking for the x, the angle, I'm going to do inverse. So it's just the sine inverse of all that. 12 sine 50 over 10. And it actually follows the same pattern if you really think about it. It's just, again, these two divided by that one is what goes in here. But now I'm looking for an angle, so I do sine inverse. So sine inverse. And again, if you have a fancy calculator, it comes in handy. But if you don't, it's not a big deal. I'll show you right now what we can do. 12.5, I'm sorry, 12. Always be careful with what you write. I was already confusing that. Know what you're writing. So 12 times the sine of 50 divided by 10. And so the angle has to be x. The angle is 66.8 degrees. Again, it makes sense because this number is bigger than the 10. So the angle has to be greater than 50. If you didn't have a fancy calculator that could do all of that all at once, just break it up in parts. Find out what 12 times the sine of 50 is first. In this case, it's 9.19, and obviously we have to divide by 10, right? And so when you do the sine inverse, you would just do the sine inverse of that 0.919. And you still get pretty much the same thing. You see I got something different, slightly different, but that's because I rounded. And yeah, that right there is the law of sine, guys.